everyone. My name is Alex. I'm the founder of ZK Sync and CEO of Matter Labs. And today I'm going to talk about the Appchains and how rollup clusters work, what they are, and what implications they have. And I will start with it's probably obvious, rollup-centric roadmap has led to transformation of the Ethereum's original vision of the world computer into the Internet of Chains, which is not a coincidence. This is like we're in blockchain and Web3, we're kind of following the evolution of computing in general and the evolution of the internet. It's the third wave where we're putting value and putting valuable state and global cooperation to the ultimate degree on the internet, on chain. And what it is going to lead to is that the apps will also transform, just like the applications on the internet got their own servers and got their own functionality moving from shared co-located environments. The same thing is going to happen with Appchains, with applications on Ethereum. There are many reasons for this, but basically we're going to go from a world of every application is deploying on a separate chain, on all of the chains, to a world where you can deploy on one chain. It might be a chain you fully control as an application, and then all the other chains are interacting together and have access to what you're doing. And we see a lot of interest for this topic from the app builders, because obviously developer experience of deploying many chains is not great. But more importantly, because you can customize your application and you can offer functions that are not possible on a uniform, like one-size-fits-all environment. And also, very importantly, you have the full ownership of what's happening there. You can control the access rights, you can control how you handle different policies, and then you can control the value flow of the application to a much higher degree. For example, you can have validators who are receiving the fees, certain other value capturing mechanisms, and then delegating this to the token holders, to the larger community of this app. So there are many very, very strong incentives. And the main blocker why we have not seen this happening so far is the lack of native interop. It's not even the lack of infrastructure. The infrastructure is there. We have rollup as a service providers. You see now hundreds of rollups being built, but many of them application specific, kind of like in their infancy. Many of them are generalized, but the cost of running your own chain is approaching negligible thresholds. And you basically get a lot of services. Everything is coming out of the box, available for you to use. But the lack of native interop is really preventing us to live this vision through fully. And I want to give you an intuition why, and then I want to walk you through the technical trade-offs of different approaches of how we can actually make this work. So this talk is mostly for application builders and chain builders, and those application builders specifically who are considering doing their app chain. What is the perfect world? Whenever we build a revolutionary technology, the best approach is to imagine the perfection, the perfect end game, and then reverse engineer from there and see what steps we need to follow to get there. A perfect user experience, in our opinion, consists of three major pillars. Pillar number one is you want to have a single account. Just like today on Ethereum, on the internet, we got to a maturity where you have your email and it's basically controlling everything you're doing on the internet, all of your accounts. And it's really easy to connect. You basically have Gmail, Connect, Apple Connect, one click, unlocks everything. We need to get to the same experience on Ethereum. Your single wallet, you don't have to maintain a plethora of wallets on all different chains and manage their complexities. That should be very, very easy. The second thing is, from this one account, you should be able to interact with any app on all of these chains that comprise the Internet of Chains that is today Ethereum. Which means no manual bridging, no manual switching of networks, and the confirmations are fast. So the same user experiences you have on a single chain should happen across multiple chains. And finally, there should be no overhead involved with these interactions. When you can transact from one chain, from your account, one chain to some application, you should not be thinking about like, oh, that's going to cost me some percentage of the capital or assets that I'm sending there because there is some bridging involved. And you should not, your security model should remain the same. Like if an app is deployed on a ZK rollup and it's a mutable smart contract, you can firmly count on it because Ethereum gives you this hardness and enforces its commitments. And this should not be violated by some new intermediaries that are jumping in between and facilitating your bridging. Right? So those three things must be held intact. And there are basically two ways to get there. As you probably know from the product world, we can try to come to a perfection at Ethereum-wide level, like have endless conversations, think through, go through like endless iterations and come with a perfect design and try to implement this, which will probably take 10 years. Or we can go through a gradual path and deliver incremental value as we go. And obviously, you can imagine which way I'm advocating for. Ethereum has always been pragmatic and embraced the second approach. So what would this second approach look like for pan-Ethereum interop that can enable the rise of the app chains? The first level, like the most basic, lowest hanging fruit, is to agree on the standards for interop across all rollups. Like the rollups that are being deployed right now, we cannot perfectly connect them, but at least we can agree on the future way how we will be connecting them, and then some definitions. And this include chain registry. It should not be a GitHub account where someone manually assigns chain IDs. It should be something permissionless and open. Cross-chain specific addresses. Again, like this is quite obvious. Like 0x something does not define your chain. We've seen like millions of dollars being sent to wrong addresses on wrong chains simply because we did not think about this when we were designing the address format in the early version, like 5 years ago when Ethereum was in its nascent state. But now it's time to fix that. So like again, we can copy, borrow some ideas from the internet, do something that is very intuitive, very easy to understand, and is fully permissionless and stepping into the chain ID registry and so on. And then we can define the APIs of how the contracts on different chains can interact with each other, not because we can do it today immediately, but because it's a lot easier to commit to something and then build towards this future. This is, in my opinion, not very contentious. Like we have conversations with different rollup stacks. Everyone supports these ideas, and this is happening. Like the conversations are happening. I think very soon a number of ERCs will crystallize that define the specifications. And it's going to be a really, really great first step. The step number 2 is the rollup clusters. Why rollup clusters? What is rollup clusters? We cannot build this perfect interop world on Ethereum today because we have a lot of legacy. Like we cannot just start and rewrite Ethereum from scratch to support these things. This goes back to like chain IDs embedded in transaction format, chain addresses not being supported. The design is not there, right? So like it's hard to change something like Ethereum. You've seen just in stock for like 5 years to get some relatively limited improvements in the base layer 1. It's really hard. But we can totally do it at layer 2s. The power of Ethereum rollup-centric roadmap is that we have this permissionless innovation. We are allowed to change things and deviate from the standard, and we can just come up with this perfect world and say, like unburdened by what has been, we're now building our own way in ZK Sync. We're building our own way, like within like superchain, egg layer, arbitrum orbits, chain groups, and we can call them rollup clusters. And what defines a rollup cluster is it's something that enables this perfect world of the UX that I was talking before within the boundaries of the cluster. So it only applies to the chains inside this one cluster. And between the clusters, we'll have the same problems as we have today at this stage, and we have the same solutions. Like we can use external bridging, we can go and bridge through layer 1 if it's some significant amount of assets. But at least we can solve it within the clusters, and there will be a limited number of clusters. It is not going to be hundreds, it's just going to be like a handful. And then, as a next stage, once we have tried and figured out what works at the cluster level, we can go back to layer 1 and say, like, OK, here are the best practices. We know how to build it. It's been battle tested. Let's now get something enshrined as a standard for pan-Ethereum interop on layer 1. So what is the stage of current maturity of clusters and what we can do there, and like how to enable this? Now I would argue that a cluster, an interop rollup cluster, is defined by two key mechanisms. You need both of these mechanisms. The one is shared liquidity, and the other is native message relay. If you only have one and not the other, you will not get the full user experience that I was describing that we need to get to the Appchain-centric world. You practically have it already, like with message relay mechanism enabled by third-party bridges, for example, enables you to pass arbitrary messages. But since you don't have shared liquidity between chains, they only work with external sources of liquidity, and this is why there are external costs and external risks associated with those third-party bridges. So you also need the liquidity there. Now, let's explore them, each of them in detail, and see what trade-offs we have and how we can actually build that. Shared liquidity, we have two approaches for this. One is each chain can maintain the liquidity locked into their TVL that is currently managed by a smart contract on Ethereum, the bridgehead that is deployed on layer 1. We can keep them separate and then coordinate. And if you imagine you have like OP mainnet has like 100 ETH total liquidity, and then Base has 100 ETH total liquidity, and then you move all of this liquidity from OP to Base through the native messaging interop, and you own it on your account, you obviously cannot withdraw it from Base, right? Because there is not enough liquidity on this bridge contract. So like you will then need to coordinate something more complicated. Like if you need to withdraw more than a single bridge contract contains, you will need to orchestrate and do multiple transactions, and you will need to build like a relatively complex orchestration framework. But this is doable. It just like adds more complexity, but like that is a plausible path forward. The alternative is to say, you know what? Let's take one contract. Let's build like a single store of treasury for all of these chains that are participating in the cluster on layer 1, and then merge it together, have some mechanism of token accounting between the chains, so we know exactly how many tokens are in each of the chains, so they don't violate each other's security. But then it makes it a lot easier to withdraw everything from a single place. Both are valid approaches and not that contentious. The native messaging is a lot more interesting. This is actually where we will see the largest divergence in 2025 and the biggest trade-offs being made. What is native message relay? You need to prove from one chain to another that something happened on the origin chain. Because imagine you have separate sequencers. You want to bridge funds. You want to transact from chain A to chain B. You're initiating this message on chain A. Chain B does not know anything about this. Their validators don't know. Their sequencer doesn't know. They need to decide that I'm going to include a transaction that modifies my state, that attests that something happened on chain A. And you need to figure out at what moment can I include this? When can I trust the source chain? And again, you have two different approaches. The optimistic approach, you have three approaches. Approach 0 is you just trust whoever is sending you this message. This is basically what we have today with third-party bridges. This is like relatively similar to how sidechains pass messages to each other and how Arbitrum Orbit fast withdrawal feature works. You just have to trust them, right? Like certain chain. Okay, that is one option. But we're talking about Ethereum. We want to derive security from layer 1. We want to preserve the security model of the rollups. We want basically all transactions to be verified by Ethereum. In this case, if your cluster is optimistic, all chains are optimistic rollups, then you can build a native interop message passing mechanism, but that will mean that every node of every rollup in this cluster will have to verify all transactions on all other chains of the clusters. So like not only the validators, not only the sequencers, every single full node. And remember, in optimistic rollups, you're supposed to run your full node to make sure that you can enact fraud proofs, to run your own, to be able to see that finalities happened at least subjectively on chain. And that means that you're basically concatenating all of these rollups in one giant sharded system. It's not really like separating them. It's like you're adding more and more, and all of that needs to run on a single node. With the ZK cluster approach, you can do it differently. Each of the chains has to generate a validity proof, the ZK proofs of each of its blocks. You can then recursively aggregate them together. You can take the state of the latest block of these chains and also recursively aggregate them, get a single root hash, put it on Ethereum as a settlement layer. And then each of these chains, so like each chain is doing like its own piece of work, not caring about everyone else. And then in order to trust a message coming from some chain participating in this cluster, all you have to do is to check the root hash of the aggregated state. And it's going to be enough for you to check, okay, some event happened, fully trustlessly rely on pure math and not on any game theoretical or like cryptoeconomic mechanisms. And that leads to like a really interesting divergence of properties. So with optimistic clusters, all of the operators that can be allowed on the cluster are essentially trusted. It's kind of this insider group. You cannot allow permissionless participation. You cannot let everyone there. You will have like 5 chains, and then to get the 6th one, you need the permission from all 5, because all of them and all of their users will have to run the full node of that new chain. And this continues. So it gets really hard to expand. Whereas in the ZK approach, you can make it fully permissionless. Anyone can join. They cannot do any harm, because the zero knowledge proofs is validating everything that's happening on their chain. And the second corollary is that the optimistic approach will be like limited in its total capacity, because you still need to make sure that the full node can be run on consumer hardware, as opposed to the ZK, which is like fully uncapped. Because this Merkle tree, this aggregation, we can just keep adding chains to this thing, and there are no inherent limits on where we should stop. Similarly, with optimistic approach, you can only rely on Ethereum data availability. You can only allow rollups in this cluster. If you allow one non-rollup, one Optimium, the entire thing then becomes an Optimium from the security perspective. Like your security model is downgrading to the weakest link in the entire thing, because your full node will not be able to attest what happened on some chain where data is not available publicly through Ethereum. Whereas with the ZK cluster, the chains participating can use custom data availability solutions like Celestia, EigenLayer, whatever you choose as a builder. And then finally, optimistic approach basically requires uniform architecture, because everyone has to fit into this into something that can be run on a single node by all participants, whereas with ZK, everyone can do their custom design, manage their policies in whatever they want, implement custom functions, implement any sequencer, centralized, decentralized, what they want. But this is becoming reality. Like we will see the first optimistic and ZK clusters going live. optimistic are going to be limited. ZK are probably going to, we're going to see more chains participating in the interop. And I'm certain that the next year is going to become the year of the app chains. Thank you. Happy to take questions.
All right, let's hear it for Alex, ladies and gentlemen. Very engaging presentation. Some very, very good questions are coming in as well, Alex. Now, you can vote for their favorite questions. Let's look at the one with 4 votes at the top. More app chain implies less decentralization, as there is no incentive to run the full L2 nodes. How do you mitigate this?
Quite the opposite. More app chains means more decentralization, because you can have thousands of completely different chains run by different communities, run by different, like some of them will be corporate chains, institutional chains with privacy, with their own things. Some of them will be run by decentralized communities with very, very different approaches to how these decentralized mechanisms work, not fitting everyone into the same, basically like a few oligarchic builders that produce all of the blocks for everyone. Like, this is the only way to actually keep Ethereum fully, truly decentralized and keep it growing in a decentralized manner.
Very good. More app chains, good. All right, next question with 6 votes. We're fighting with 2 questions there. Who is working on standardizing interop? Oh, excuse me, it went to the... Where did it go?
Okay, the second one, yeah. We have a group between different L2s, the leading L2 stacks, and we're making quite some progress there. I think by the end of the year, we'll have this RC standards kind of well spelled out.
Excellent. Go to the top one. What do you think about ERC 7802 by Wonderland, Uniswap, and Optimism about bridge agnostic cross-chain token interface? It's a nudge.
We just posted the a tweet on support for the standard, because it's, yeah, obviously that's one great example of how things can work at this stage 1 of coordination.
Excellent. Lots of questions getting voted up. Now, this one with 8. When stage 1 for ZK Sync era?
It's most likely going to be in Q1 next year. It's the next thing on the priority. It's very, very important for us. ZK Sync has always been committed to like very deeply go on cypherpunk values and be a pioneer of that. And the only thing missing is the priority queue. Everything else is in place for. But like, it's almost stage 1 today with the missing of this one component, which is going to be finished.
So very, very close. For those of you who are waiting in anticipation, Q1 next year, look out for it. 6 votes at the top. Security first. Do you agree that L2s and app chains increases throughput but don't reduce latency compared to L1?
So the latency of this approach is going to be like the hard latency of fully trustless interop with native message, with native asset bridging, will be determined by the latency of proof generation. The latency of proof generation is going down massively because it's a fully parallelizable thing. In the design of the new proof system, the Bootjam 2.0, the new Bootjam virtual machine that zkSync is having, it's something like on the order of minutes, and then it's coming down to seconds, and I'm sure we'll have full, like close to real-time proving in the next couple of years. Until then, we can do something interesting. Like we can use less secure proofs, for example, TE, SGX proofs, to make the message passing faster, and the chains who are willing to accept those proofs for a short period of time under the risk of reorg, and like this is important, only reorg of this like last 1 minute, not any other security violation, they will be able to enable practically instantaneous interop, like under like with 1 second latency, because the most blocks in the ZK stack specifically are going to have 1 second.
All right,
so
50 seconds. Let's do the last question at the top. How is it different from the Polygon egg layer?
It's very similar in design. I think it's more mature. We have the shared bridge live today with 3 chains live: zkSync Era, Kronos, Zero, and a dozen of others launching on this shared bridge. And the interop is becoming production ready by the end of this year, and then it has to pass the audit and governance. I'm pretty sure it's coming like early next year in full integration. Yeah.
All right, that's all the time we have, I think, for today. Ladies and gentlemen, let's give Alex a big, big round of applause. Well done, well done.